Hello and welcome to this presentation on formal languages and grammars. Today we will explore various aspects of language structure including a subset of English grammar, postfix notation grammar, extended Backus Naur form and example with derivations. Rules for constructing valid sentences. Let's start with the rules for constructing valid sentences. Sentences must have a subject and predicate, both agreeing in number and tense. Proper punctuation, including capitalization at the beginning and appropriate punctuation at the end, is crucial. Additionally, sentences should be grammatically correct and coherent. Subset of a English grammar. We then delve into a subset of English grammar, covering noun phrases, verb phrases, and prepositional phrases. For instance, a sentence consists of a noun phrase followed by an intransitive verb phrase and another noun phrase. Valid sentences examples. We illustrate these rules with examples of valid sentences like John runs, the cat jumps, and the book is on the table. Validation of sentences. We proceed to validate sentences using a set of productions. For example, the happy hare runs is broken down into a noun phrase, intransitive verb phrase, and another noun phrase, each following specific grammar rules. Derivation trees. To visually represent the process of generating sentences, we construct derivation trees. These trees show step-by-step production rules for sentences. Let's create derivation tree for sentences like the happy hare runs. Phrase structure grammar. Moving on, we introduce phrase structure grammar, a formal grammar prescribing language structure. We implement a phrase structure grammar for signed decimal numbers using code segments and parser. Constructing a phrase structure grammar. We define the grammar rules for signed decimal numbers in the Backus Naur form and illustrate it. The rules cover signs, non-negative integers, decimal, fractions, and positive integers. More phrase structure grammar examples. Expanding our exploration, we provide production rules in EBNF for different identifier scenarios, including lowercase letters, uppercase letters, and combinations with digits and underscores. Extended Backus Naur form. Next, we introduce extended Backus Naur form, a notation allowing optional elements, repetitions, and more. We present production rules for decimal numbers in EBNF, specifying optional sign, non-negative integers, and decimal fraction. EBNF for C programming language identifiers. We extend our EBNF exploration to cover identifiers in the C programming language, incorporating variations like starting with a letter or an underscore and including alphanumeric characters. Postfix notation. Shifting gears, we discussed postfix notation, an alternative to infix notation. In postfix notation, operators come after operands, contrasting with traditional infix notation used in mathematics and programming languages.
Postfix notation example. We then analyze strings in postfix notation, determining if they are generated by provided grammar. We illustrate steps used to generate or not generate strings like these.
Infix notation with BNF. Exploring infix notation, we describe its syntax using Backus Naur form. We then evaluate strings like x plus y plus z against the grammar rules, demonstrating the step-by-step generation process. Automata construction. Transitioning to automata, we construct a finite automata, a pushdown automata, and a Turing machine to accept specific language sets. We also verify strings against these automata. Turing machine for language 01 plus 10. We design a Turing machine to accept strings in the language 01 plus 10, showcasing the steps taken by the machine in processing an input. PDA for CFG. Finally, we built a pushdown automata equivalent to a given context free grammar. We test the PDA against a specific string to determine its acceptance. Thank you for joining us on this journey through formal languages and grammars. If you have any question or would like further clarification, please feel free to reach out. We appreciate your time and attention. Thank you.